welcome to my channel. Today we are going to talk about DFS. DFS is an algorithm for searching a graph or tree data structure. The algorithm starts at the root node of a tree and goes as far as it can down by a given branch, then backtracks until it finds an unexplored path and then explores it. The algorithm does this until the entire graph has been explored. Many problems in computer science can be thought of in terms of graphs. For example, analyzing networks, mapping routes, scheduling, and finding spanning trees are graph problems. To analyze these problems, graph search algorithms like DFS are very useful. The time complexity of DFS algorithm is represented with order of V plus A. As in the worst case scenario, every edge has to be considered once and every node has to be visited once. The space complexity of the algorithm is order of V, as the more number of vertices needed, the more space is required. DFS is used in pathfinding. We can specialize the DFS algorithm to find a path between two given vertices. And DFS only can be used in detecting cycles in a graph. A graph has a cycle if and only if we can see a back edge during DFS. So you can run DFS for the graph and check for back edges. Also can test if a graph is bipartite or not. Along with that, we can use DFS in scheduling jobs from the given dependency among jobs, and stuff like maze solving, data serialization, logic synthesis, etc. can be done with DFS. So DFS is really a great tool in the computer science arsenal. Now we will see how DFS works. First, we will start from 0. From 0, we can go to 3 directions, 3, 1, 2. We will choose 1 as it comes first in numeric sequence. So now 1 is discovered. From 1, we can visit 2 for the same reason, although we could have chosen 5 or 8. Now 2 is discovered. And from 2, we will visit 8, 7, 5, 4 accordingly. In node 4, as there is no edge, so we will denote node 4 as finished. From there, we will backtrack to 5. 5 still has an unvisited node, which is 6. We will visit and discover 6. From 6, there is no unvisited node left. So we will denote 6 as finished. Now we will again backtrack to 5 and denote 5 as finished, as there is no unvisited node left. From 5, we will backtrack to 7, 8, 2 and denote them as finished. And now we will backtrack to 0. From 0, there is an unvisited node 3 left, so we will visit 3 and discover it. From 3, there is nowhere to go, so we will also denote 3 as finished. Now we will backtrack to 0 again and denote 0 as finished. Now only one node remains, which is 1, and we will assign 18 on it. Now we will see how to implement DFS in C++. In this part of code, we declare some variables and have taken user input. We also initiated the finished node. Now we'll take a for loop and another loop inside it. If the path is not 0 and visited, and visit is not the first node, then assign the first node to visit and then make it to the top element of the stack and increment the top element. This is what we gonna implement in our code. Now backtrack and decrement the top element of the stack and assign it to V, and then assign 0 for discovery and 1 for finished visiting. Our number of vertices is 9 and number of edges is 15 and edges are 0, 3, 1, 2, 1, 5, 1, 8, 2, 0, 2, 8, 3, 1, 5, 4, 5, 6, 6, 1, 7, 1, 7, 5, 7, 6, 8, 7, and we will start traversing from 0. And this is our DFS order. Thank you everyone. Thank you for watching this video. I hope you will all have a happy day. Bye.